Hi there, my name is Sophia and today we'll be talking about the security risks of the cars of the future. So first, a little bit about me, which has previously actually been mentioned, but first and foremost, I'm an admin for Ladies Cheltenham Hacking Society. I'm also a security consultant for MCC Group. I recently graduated university last year, as well as founding the brand Security Queens. I was also team captain for ECSC in 2019, and you may have seen me on TV as a cyber hunter on Channel 4's Hunted. In recent years, I've also won a few awards under my belt, including Best Cybersecurity Student. So, automotive hacking, why is it actually bad? Well, first, a quick introduction to CNI. When we talk about national infrastructure, we're talking about the things that a country depends on to function in day-to-day life. And surprise, surprise, transport is in there. So, about 40 or 50 years ago, similar to the cars on the screen, we were basically driving around tin cans on the roads. But now with a predicted 18 million connected and autonomous vehicles available to the public by 2030, we're now pretty much driving computers on wheels. With most modern vehicles that are connected in some way or form, autonomous vehicles will require more embedded technologies to achieve full autonomy. So we see this paradigm shift from physical security to cybersecurity, with attack surfaces growing beyond just physical attacks. And if you're a car fanatic like me, you might have recognized those three minis from the Italian Job. So now we continue about automotive hacking and why it's actually bad. Well, when you see headlines like these, and when you see words like this, it can be quite concerning. So first, we're going to talk about the risk components within connected vehicles and how we can attack them. So firstly, we're going to talk about in-vehicle infotainment systems. This could be something like your CyNam or your multimedia devices, such as Bluetooth, USB, and Wi-Fi. It may play your radio, but it usually has an in-cabin driver display as well, and provides us a hub for software and firmware updates. Commonly, you can attack these systems through malware injection via the USB port, and you can start to tamper with the software and firmware uploaded to that system. You can also jam the various different technologies, such as Wi-Fi, Bluetooth, GPS, and you can start spoofing and sniffing that data too. Now, ADAS systems are, again, a very common component of most modern vehicles. It combines various different functions and sensors, such as ABS, TPS, and emergency braking, and this is commonly displayed on the IVI system within the car. This particular system can be adapted for autonomous vehicles and integrated into driverless technologies, which we'll talk a bit about in a moment, and also incorporate V2X communications and smart city integration. There are various ways you can attack these systems, most commonly denial of service, but you can also tamper with the configuration and spoof some of the sensors attached to that system, as well as attack IVI itself. Now, OBD2 and CAN bus, historically probably the most popular way to attack a car. OBD2 ports are ports that are used to diagnose faults within the vehicle, and because of this are legally required by all manufacturers. The OBD2 port provides the central gateway for the CAN bus inside the car. A CAN bus is a peer-to-peer physical network inside the car that connects a whole range of control units so they can talk to each other. Different components usually mean different control units. It's quite easy to manipulate this CAN data through that direct connection in the OBD2 port by spoofing, replaying, or crafting your own messages to hijack ECUs, or you could perhaps flood CAN data to completely jam that OBD2 port itself. PCAS systems, my car actually has this itself, makes me quite paranoid, but this is very common in modern vehicles. It basically replaces traditional car entry by improving user experience and improving the efficiency in securing cars. You can just walk up to the car, not even have to take out your bag, and it will unlock the car or lock it as you walk away. It's needed to start the vehicle, and it will not start if the key is not in the proximity of the car, and uses a special type of cryptography to identify key fobs. The most common attack in this particular technology is relay attacks to open and start the car, but again, you can try jam it or even clone the key to then walk up to the car and try open it. Telematics devices, often used by insurance companies. They use positional data to kind of gauge how your car is being driven. So when the car is being driven, your driving style, it uses the control unit and communicates with the TSP over some cellular infrastructure to try and get there. Again, you can try spoof the data being uploaded to the platform, or you can try jam or sniff the data, or even compromise the associated user accounts on the UMI. And finally, over-the-air software and firmware updates, again, common in modern vehicles. This allows vendors to remotely deploy updates to the vehicle and its embedded components and software. It helps fix issues or bugs, upgrade security, upgrade functionality, and also deploy new functionality. You can insert these updates and actually try tamper or modify them through a man-in-the-middle attack, or you can try perform a DOS attack whilst it's in transmission or in storage. So now we're going to talk about autonomous vehicles. Is this the future? There's a predicted 8 million autonomous vehicles available to the public market by 2025. This means completely driverless and completely roadworthy for the public highway. Commonly, autonomous vehicles will use something called a V2X infrastructure, vehicle to everything. Using both 5G cellular and intelligent transport systems, it will try to integrate itself into smart city infrastructure, providing environment, traffic data, and safety alerts through real-time broadcasts. So now we're going to run through how to attack those. So the most important component of an autonomous vehicle is the AI and machine learning components itself. These are used to achieve a higher autonomy, and the algorithms help the components within the vehicle perform decision-based tasks to improve the ability to predict situations, which prove incredibly safety critical. So using AI and machine learning helps improve the driver automation in accordance to the SAE J3016 standard for defining levels of driver automation. Right now, we're between sort of 0 and 2, perhaps a little bit of 3. And when we move towards the future of a completely driverless vehicle, we're looking between 3 and 5. Surprise, surprise, you can perform a denial of service attack on these driven sensors, but you can also spoof fake data or inject your own data into the algorithms to try attack it as well. AI and machine learning components use all sorts of sensors to try assess the environment. One of this is cameras. Cameras react to the surroundings and alert the driver, usually through the IVI system, such as lane departure, traffic moving, or a collision alert. And this helps the vehicle map its surroundings in cohesion with other sensors such as radar and LiDAR. So you can, again, perform a denial of service against a camera through a blinding attack, or you can even manipulate scenery to fool the sensor to project fake obstructions or fake signs. Another autonomous sensor used is LiDAR, and helps AI and machine learning components, again, help visualize the assessment of the environment. What LiDAR is, it's basically a sensor that rotates on top of the car, emitting thousands and thousands of lasers to help detect objects. When that laser bounces back, it will measure that distance and then create a 3D map of the environment. It's quite easy to spoof LiDAR and detect objects that aren't there. And again, you can jam it as well to perform a denial of service attack, but you can also do replay relay attacks to detect objects that aren't there by replaying parts to the sensor. And finally, let's just have a little chat about V2X communications. This particular infrastructure implementation allows vehicles to communicate with each other and the environment. It's very, very prominent in smart city infrastructure, and it improves passenger and driver experience, as well as safety and efficiency. Example data includes personal data or perhaps sensor and vehicle data. It's quite unfortunately easy to sniff this kind of data through a man-in-the-middle attack, or you can either manipulate or replay that data. And again, you can perform a denial of service against this infrastructure as well. So automotive and smart cities, what could actually go wrong? We've talked a lot about how you can attack these cars. So things like data theft, by credentials or vehicle data or location data. Of course, there'll be a major disruption to CNI if you can start tampering with smart city infrastructure involving autonomous vehicles. You might have the threat of hacktivism or pranking by script kiddies, but it's most likely there'll be some sort of financial gain from this through ransoming and selling data, or perhaps stealing the vehicles itself. kind of moving up the severity of the attack. You could even have something called cyber espionage, where advanced persistent threats are trying to target and cripple rival nations. So I appreciate that's been quite a quick run through of what can happen with hacking cars and smart city infrastructure, but feel free to reach out to me on either of those platforms, and don't forget to check out Ladies Hacking Society and Security Queens. Thank you.
Gosh, thank you, Sophia, so much there. I'm just glad that I'm cycling home tonight and not driving in my car.